Hello, welcome to the third installment of the Chapter 21 lecture videos. This installment is going to cover volume per hour, and this begins on page 328 of the textbook. So volume per hour, or milliliters per hour. This is going to help us determine the amount of fluid or solution that will be administered to the patient intravenously per hour. Unlike flow rate duration problems, volume per hour problems are going to be solved through ratio and proportion, and then we're going to cross multiply to solve for X. So let's look at what we are talking about here. And I feel like most of us are pretty good with the solving for X. So hopefully this will go pretty well. So example 21.11 says a patient is to receive 750 milliliters infused over 3 hours. What is the rate of infusion in milliliters per hour? So we're going to set up a ratio and proportion and then solve for the unknown. So we know that we are dispensing 750 milliliters, and we know that that is going to take 3 hours to administer. So we have 750 over 3 hours equal to X, because we're trying to determine how many milliliters over the 1 hour. And then we're just going to cross multiply. 3 times X will give you 3X. 750 times 1 gives you 1. I'm sorry, 750 times 1 gives you 750. And then we have to isolate that X. It's currently being multiplied by the 3, so you're going to have to divide by 3. And what you do to one side of the equal sign, you must also do to the other side. So on one side, we get that X equals, and 750 divided by 3 is going to give you 250. So we would be administering 250 milliliters per hour with the scenario that was presented to us. So let's look at a couple of example problems. Let's start with example 21.12. (21.12) says we have 250 milliliter IV containing 1 milligram of Isuprel. It is to be given over 100 minutes. What is the rate of infusion in ml per hour? Well, we have a 250 ml IV. And remember, with ratios and proportions, when we set these equations up, we have to keep our like units in line with one another. So if I list mLs as my numerator on one side of my equal sign, mLs must also be my numerator on the other side of the equal sign. If I list hours as my denominator on one side of the equal, hour has to be my denominator on the other side of the equal sign. So we have 250 mLs, and in this particular example, that is being administered over 100 minutes. And we're trying to find out how much medication. So I'm going to denote that with X, and I just put the ml there. And again, with that blooming glare, that is ml under that glare. I just notate my unit of measure for myself, so that when my answer comes out, I remember which unit of measure it should be. So this is in minutes, and my equation is asking me, what is the rate of infusion in milliliters per hour? Well, I'm in minutes. How many minutes make up an hour? 60, right? So we can set it up as such. That'll give us per hour, because 60 minutes is the same as an hour. And then we're just going to cross multiply. 100 times X gives me 100X. 250 times 60 is 15,000. Now, this X is currently being multiplied by 100. So I'm going to have to divide by 100 to cancel that out. And what I do on one side of the equal sign, I must also do to the other side of the equal sign. So on the left of the equal, it leaves me with just X. And 15,000 divided by 100 equals 150. And remember, that was milliliters per hour. And I remember that this should be milliliters because that's what I was looking for, right? Let's do another example. We'll do 21.13. Example 21.13, this is on page 329, says we have 500 milliliters of D5W, that's dextrose 5% in water, containing 1 gram of lidocaine hydrochloride that is to be given over 250 minutes. So what is the infusion rate in milliliters per hour? So again, we're starting with 500 milliliters, it's your starting volume. And my starting time, so that this is being administered over 250 minutes. And they're asking me how many milliliters in 1 hour. And again, I'm going to use 60 minutes, just simply because this was given to me in minutes. And remember, my like units of measure have to be the same. I cannot have minutes on one side and have hours on the other side. My equation won't work out correctly. All right, so then we can cross multiply to solve for x. 250 times x gives me 250x. 500 times 60 gives me 30,000. My x is currently being multiplied by 250. So I need to divide by 250 to cancel this out. That leaves me with x. And what I did to one side of the equal sign, I must also do to the other side. So 30,000 divided by 250. It comes to 120 ml per hour. So I hope this video has assisted you with volume per hour calculations. As always, if you still have a little confusion or something's not fully clear for you, just reach out to me and we will get that worked through together. Because again, you're going to need that to be able to conquer the next math as well. So hopefully this is helping you out, and I will see you in the next video installment for chapter 21. Until we meet again, bye-bye for now.